I'm back here again, and this time on a different subject. And today I'm going to talk to you about our 5-axis solution. Emil told me to convince you that we are the best. For that, I need to get convinced myself first, and I can then convince you. How do I convince myself that we are the best? By looking at stories around the territory that I look after. And one of the, stories that I'm going to tell you today has convinced me that not only we are the best, but we are the best by far. Okay? So this is the agenda that I have today. I'm going to explain to you about, you already know this. You have already seen this portion of my presentation already many times. And I'm going to explain to you about our Sim5X offering that we have. And then we are going to see some new things that we are introduced in 2023. And what is our future as far as Sim5X goes. I'm going to talk about that. And then I'm going to show you a very powerful customer story. In fact, I'm going to talk to you about two customers. One of them I'm going to talk to you right now. And the other one, of course, it's with pictures and statistics and stuff like that. But the first one, unfortunately, we did not get the permission to talk about. But I'm going to talk to you about that particular deal that we had and why it convinced me that we are the best. And then finally, I'll summarize with the entire presentation. So while this slide is going on, I would like to explain to you what we are offering in 5-axis. So you know the 8 items that are already there. Okay? We have the generic, we have multi-axis machining, multi-blade machining, port machining, rotary, edge braking, edge trimming, and Auto 3+2. 2023 will see a new launch of a completely new module inside 5-axis, and that's the turbo unified 5-axis engine. So whatever we saw yesterday in 3-axis is available to us in 5-axis. So you can use 5-axis as if it is doing 3-axis machining. So wherever the holder comes in contact with the part or where it's very close to the part, SolidCAM will automatically tilt the tool to machine that area. So you can use short tools to machine really deep parts. Very important for die mold area where they actually use 5-axis. Many of them are now using 5-axis to do mold machining. Okay, so let me talk about the generic for 5-axis machining. So it's a perfect solution, first of all, for 5-axis machining needs. It can machine any part the way you like. And it also features a user-defined collision check, lead-in, lead-out, and stuff like that. Now I'll tell you a story. I was in the market, and my colleague called me up, and he says, we have a part, and the customer wants to know if we can do the part. So I told him, just send me the file, and I would like to look at it. So he said, I've already sent you, have a look. So I opened the Open Cascade application on my phone. I opened the part, and I said, and then I called him after I looked at the part, and I said, why does he need 5-axis? It looks like a 3-axis part to us. He said, no, it's a 5-axis part. Go back home, look at it very deeply, and then let me know if we can do the part. So when I reached home, I opened the part in SolidCAM, and I started checking the part. The part was really complex. It was not as it was looking on my mobile phone. It was a 3.6 meter part divided into 3 segments. And each segment had about 150 pockets. And each of those pockets was connected by a groove that was 15 millimeter deep inside and changing over as it moved onto those 150 pockets from 15 millimeter to about 6 millimeter throughout. And in between, it had got ribs into the groove. So it was extremely complex part. And the groove, the only way to machine was to use a slot and mill to machine in 5-axis. The most easiest tool in 5-axis is a ball nose tool. Everybody agrees? The next easiest is a bull nose tool because of the radius. The difficult tool is a flattened mill. And the most difficult tool is a slot mill to move in a 5-axis movement. So I sat that night and I said, does the customer really want us to machine this part? They said, yes, you have to do this part. So I created one program inside using our generic, just one line, because I wanted to know if it really works. So SolidCAM did create the program, and I told my guys, don't give the customer the program, just show it to him on the screen, get a confirmation that he's going to buy our product, and then we will see it further. So my people went the next day to the customer, showed him only the video of the program that I did, and the customer said, okay, let's talk. After he finalized the product, he wanted us to cut the part. So he asked us the timeline to cut the part. His timeline was 1 week. I don't know what he was smoking, but that particular part was going to take approximately 2.5 to 3 months of cutting on and of programming. So we started programming the part, and my people went there, my engineers went there to cut the part. The part was so huge that 2 people had to stand inside the part when the machining was going on to find out where it is cutting and how it is cutting. Because it's very difficult, once the tool enters the groove, it's impossible to see what it is doing. So they had to check at every point how it is working. Each segment was 1,200 programs. Each segment, 1,200 programs. Each segment, 18 gigabytes of data. Even to open the part, it used to take 6 to 7 minutes just to open it back in SolidCAM. So we had 3 such segments to cut. Now, why was I convinced that we are the best? This customer first bought NX to cut that part. NX offered them all kinds of dreams, that they will do the part, they can do anything in the world, the entire world works on NX, and we can easily cut the part. So he waited for 2 months for them to come and prove the post and cut at least 1 segment. They never came back. In fact, they were supporting from Singapore. Not even the Indians were ready to support for that part. So the company from Singapore was supporting it. So they failed, and then the customer went to Esprit. He went to Esprit, they said, we will do it, buy the licenses. He bought 2 licenses. Esprit never turned up, because once they saw the part, they just couldn't do the part. And then came our friends from Open Mind. Big stories, because they are the best. They think they are the best. And they were shown the part. They saw the part, and they never came back. The customer was so frustrated that he kept following up from them, because he had got very good reference from DMG and Hamle for that particular part. So they never turned up. He then went to Mastercam. He then went to CamWorks. Everybody looked at the part, disappeared. The only people who said, yes, we could do it, was SolidCAM. And as we speak now, as I speak now, we have just completed the 3rd segment. Next year, wherever the conference happens, because I don't have the permission now to talk about that part in depth, but the next year, the customer has promised to give us all the data, and I'm going to present that because it's a very, very prestigious part. Okay? It's so prestigious that the customer says, please don't talk about the part. Okay? Next year, I'm going to present that, and I'm going to tell you why we are the best. And all this, when it was happening, made me realize one thing, that our competitors talk, especially Open Mind, they talk when there is an automation involved into it. They're very good in automation. Okay? It's like driving a car on a nice Autobahn highway. As long as they are on the Autobahn, they're very good. Take them on the dirt track, and they will not even move an inch further. This is what I have realized after going through tens of cases against where we have won against open mind. So, first thing I would like to tell you, don't fear them. Okay? You have everything in your ammunition, you have automation, and the best thing, you have generic. It can do anything. It can do wonders. And trust me, with SolidWorks next to our product, it helps in a big way to reconstruct surfaces to make them work much better. This particular part that I talked about, my engineers created more than 900 surfaces to make the toolpath run very well. It's something unheard about. Okay? Generally, it's just a part, you pick a surface and it starts machining. But not in this case. We had to create close to 900 surfaces per segment to make the toolpath run exactly the way it had to run on the machine. So it's a big, big deal for us when we say that we have done that part. Next year, I promise you that I will show you that part, how that part looks like, and how it was done. Then we have rotary 4-axis finishing. You already know about this. It's more for cylindrical parts. It's a 4-axis finishing toolpath engine. Machines, more of a cylindrical parts, more for jewelries and electrodes. We also have the swarf machining, something that no customer can work without today. We can do any kind of surface with swarf, whether it is a straight surface or even if it's a curved surface, we can still use swarf to machine it. It's more or less an automated function. Then we have the 3 and 5-axis conversion. This, you may not need it anymore in the future because we have the turbo 5-axis milling. Turbo 5-axis milling works exactly like Auto 3+2 or the auto conversion. Okay? But the difference here is that the tilting is applied right at the calculation stage, and not you create a 3-axis toolpath and then apply tilting, but the tilting gets applied right in the 3-axis stage, in the calculation stage itself. So it allows you to machine deep paths. It's an automatic process. Improved surface quality because you're using smaller tools. And then we have our multi-axis drilling for machining the holes from different directions. Automatic depth definition or detection, and it's a very powerful tool. Contour 5-axis, not sure how many of you use it, but it's a very, very powerful tool which allows you to do chamfering and trimming operations right in the generic package itself. You don't need anything special, and works without surfaces. One of our biggest ammunition that you have today, okay? Trust me, whichever customer that we have trained very well on geodesic has stopped using the generic 4-5-axis and moved completely to geodesic just because of the sheer surface quality that it generates. It generates an amazing surface quality in 5-axis because it gives you a possibility to maintain the sidestep at a very consistent level, irrespective of which direction it's looking from. Then we have the Auto 3+2 that we released last year. So a part like, let's say, a Pelton wheel can be easily done using the Auto 3+2, where you don't know any direction. The software finds out the direction and then does the roughing as well as rest roughing functions. Very contentious issue because from last 1 year or even more than that, we have been getting a lot of requests on the automation functionality of our circle end mills. It's basically a very, very interesting tooling line which allows the manufacturers to reduce their cycle time by almost 90%, as claimed by the manufacturer itself. And we introduced the support in the generic 5-axis milling way back in 2019. However, in the last 1 year, we have done great deal of work. I don't know how many of you have worked with our multi-axis machining. Can you raise your hand? Just with the wall finishing and floor finishing, how many of you have worked? Well, we have a problem here. Our wall finishing and floor finishing has undergone radical changes. When I say radical changes, I really mean radical changes, because I remember sitting with Module Works every third week, meeting them just for this subject, for end mills, because a very strong request came from our friends in UK. And they had an account where they had to show this. So we have been working very hard on this particular subject. And today, we have made great improvement in these two functions for machining floor and wall surface using our barrel tools. It's a completely automated solution. Collision checking is part of the calculation itself. And more or less, you don't need to do any kind of surface modifications or anything of that sort. You can just pick the entire target, pick your wall or your floor, and it generates the program by itself. So everything is mostly automatic. So I want you to, when you go back from this conference, start exploring these two functionalities. These are really very powerful functionality that we have developed over the last 1 year. Of course, multi-blade, in fact, the part that I'm showing you was done by our customer itself. So it works very well. It's a very powerful engine. I have put the word here called blisk. Blisk is completely different from an impeller. But what I would like to show you when I come to the end is that starting 2023 SP2, we will have a completely automated solution just for machining blisks, apart from impellers. Everything is automated. Root fillets are handled with ease. And there are separate strategies for roughing, blade finishing, fillet, and hub finishing. Jump to the port machining. This is for machining cylindrical tube-like components. This is again an automated solution. It can handle both roughing, rest roughing, spiral, and finishing. It works in 4-axis as well as 5-axis mode. Rotary machining was earlier called screw machining because we thought that it could only do screws, but it does much more than screws. It can do any part that rotates on a 4-axis machine. Okay, so it can handle both roughing as well as finishing functions. Now, the best part about rotary machining is it's nothing but our 3-axis unified engine. Okay, the 3-axis unified engine with slicing in cylindrical space is called rotary machining. Nothing new. It's absolutely like a 3-axis function. It works like 3-axis, but the slicing is done only in the cylindrical space. So the user only selects the part, the stock, the tool, depth of cut, and sidestep. Everything else is handled by SolidCAM's rotary. Edge braking, our new entrant, which looks very, very simple, but can save major amount of time for the customer on the machine. My customer's story that I'm going to show you today, he bought in one go 8 licenses of edge braking for his company, and today all of his edge braking is done automatically on the machine, even without the user touching any part of the edge braking process. So we have done again a lot of improvements in edge braking. Now it supports flattened mills. It can handle edges where there are no chamfers or there is already a chamfer provided in the design, can also be handled by edge braking. Edge trimming, this is for vacuum forming parts and composite parts. And it's an automated algorithm, again, that if you just give the part, it will generate the tool path for edge braking. Let's see what we have in store for 2023. Now, I'm going to talk to you about 2023 in phases, okay? Not everything is coming in one go. The first thing that we changed is in geodesic, where we have got a behavior change of the engine itself, and especially there are holes in part. So this was the result in 2022 if there were holes in the part. Whereas in 2023, there's just a small checkbox. It says fill holes, and you click on the fill hole, and that's the result of geodesic's toolpath in 2023. In edge breaking, like I said, it can now recognize unsharp edges. That means if the part already has a chamfer, okay? If the part has a chamfer in 2022, it would not recognize that because it was already, the edge was broken. But in 2023, it can now recognize edges that have already been chamfered in the part. It will run the tool again in those areas to give you the edge breaking effect on those particular chamfered surfaces. Another very important thing that, like I told you, that we released Turbo 5-axis milling. Turbo 5-axis milling is nothing but your 3-axis engine itself. With the 3-axis engine, we have now given it an ability to tilt the tool right at the calculation stage itself. So you can now do constant Z machining, linear machining, constant cusp machining, rest machining, all of these functions in 5-axis. Okay, you don't need to do any kind of tilting. It's right in the page itself. So you just provide the tool with the holder, and the software will automatically tilt the tool whenever the tool is going to come in contact with either the stock or the part. So it allows for machining complex features without undercuts. Now, this is a very important thing. The part should not have undercuts. Now, what happens when parts has undercuts? It will just ignore it, leave it. In the version coming further, we will be able to handle parts even with undercuts. So if there is an undercut, it will go and machine the undercut automatically by tilting the tool into the areas. So it's an automatic generation, totally automated. There is no user control over this. The user only selects the type of tilt he wants. There are only two options. Either it's dynamic or optimized. And all standard patterns are available, like constant Z, linear machining, constant cusp machining, rest machining in constant Z, and the combination toolpaths, like constant Z as well as linear. Another very important thing that you will not see in the product, but it is going to make a dramatic difference in the product. All these years, in any of the simultaneous 5-axis toolpaths that we had this geometry being stored in every toolpath, okay? So if, let's say I have got 10 toolpaths, and I have got the same geometry being selected for all those 10 toolpaths. Let's say faces 10, and it had got some 10 faces. And the size of this geometry, let's say, was 100 megabytes. So 100 megabytes multiplied by 10 was 1 gigabyte. Your file size used to become 1 gigabyte, correct? Now, in 2023, towards end of 2023, you will see a structural change in the file system when it comes to 5-axis, or any toolpath that has been made using the Module Works technologies, whether it's impeller, multi-blade, port, edge breaking, generic 5-axis, or geodesic, anything. We are going to see a structural change in the file system. What we have done is we have separated the geometry out from the toolpath. The geometry now no longer gets stored in the toolpath. So what happens now? If the same geometry is used at 10 different places, the geometry will be stored only in one place, and it will be referenced from 10 different toolpaths. So the size of the toolpath will be in few kilobytes and not megabytes. So the file that was originally going to be 1 gigabyte now becomes 100 megabytes. We are compressing the entire file system by almost 70 to 80%. Now, during our tests, what we have seen is that the open rate of the file goes dramatically up. Like a file that would take, let's say, a minute to open on your system now opens like in a couple of seconds, because there is no geometry for it to display in each toolpath. Only when you click on edit, it brings the geometry from the referenced area. So this is a huge change that we are making as far as our structure of the file system goes. You may not see it anything outside. There is nothing new feature, but it's going to make a big difference to your performance. Your calculations are going to be faster. Your open rates are going to be faster. Your entire project size will shrink down almost by 70 to 80%. So we are making this structural change. It should be available to you under beta options by December. And you can start working and checking this whole concept. We don't want to release it to the user because it's a very, very complex project. And we don't want issues cropping up. So we would like first you to test this whole thing before we release it out to the customer. So we are looking at a release date only in 2024. But for you as a reseller, for you as a user of SolidCAM, you will get this somewhere in December. It will be opened up for you in the beta options. Okay, so the summary, we have a very complete and a very powerful 5-axis solution. We have a most trusted 4 and 5-axis engine today. And as customers grow with us, I am more and more convinced that we have really a very powerful solution. It's very easy to learn with a very easy to use GUI and has a complete control over all aspects of the toolpath. Full collision avoidance, and we have specific machining strategies for multi-blade, for port, for die mold, aerostructures, name it, and you have it. Edge deburring and turbo 5-axis milling along with edge trimming, they complete the offering. I always say that let's look into the future. This is the first option that's coming immediately. Probably in SP2, you should have blisk milling. The blisk milling is a specialized function just like multi-blade machining, okay? Nothing extraordinary, just take the tool, pick the surface, and it does the machining. No need to define any kind of other geometries. So they are complex rotating components that are made of multiple blades on a disk. And it creates a very smooth toolpath. We have already evaluated this. We have tested this. And we have got roughing, blade finishing with variable offset. Now in blisk, there is a trick. It's unlike multi-blade. You don't have the same offsets on all the passes. You have variable offsets using the U and V points, and that particular functionality is now available in our blisk machining. So you can now have variable offsets, the UV offsets, and that can be defined either in a text file and imported to the blisk machining, or you can just define it on the GUI itself. And we support all standard tools. Okay. I would like to talk about the pudding that we have been eating in India for a very long time now. And one of the customer is the oldest customer for SolidCAM. I should have talked about this customer way back, but I think now is also a very good time to talk about this customer. And why I'm so proud about it, I'll explain to you. Name of this customer is SimTools. It's no longer called SimTools, so if you find SimTools, you'll not find it anymore. It's now called as Motherson Aerospace. They've been bought. So this is a company that was in Bangalore. They started off in 1997 with just one second-hand Cincinnati machine. I sold him, or rather we sold him Cimatron at the time. He had brought Hypermill. He was not happy, so we converted him from Hypermill to Cimatron. And after that, he grew. So he worked as a vendor for Hindustan Aeronautics, small vendor for them. It's one of the largest aerospace companies in India. And they became a supplier, a certified supplier to Airbus in 2000. It did not stop there. They went on to become one of the most prestigious suppliers to Boeing in 2005. So now this company had two plants, one catering exclusively to Airbus, one catering exclusively to Boeing. They expanded when they moved into the special economic zone, when they became the supplier to Boeing. In 2020, they became a certified supplier to the European Safety Agency, ESA. Big thing. It's a very big thing, because the moment you become a certified supplier to ESA, the market opens up. And currently, they have got work for the next 10 years. They don't need to take any more work. They're full with work for the next 10 years. So what do they do? They basically do sub-assemblies, small and medium-sized sub-assemblies, both for Boeing and Airbus. How many of you flew A320 when you came to Istanbul? Do you even look outside when you sit in an aircraft, which aircraft you're sitting in? How many of you flew Airbus A320? Because Europe to Istanbul, it's a short to a medium haul, so A320 falls within the range. Next time you're sitting on an A320 aircraft and you're sitting next to the emergency door, remember, the door was done on SolidCAM. So it's a very big one. And it's been done by this supplier. And when you're sitting next to a window, just glance outside the window, you'll see two wings on either side. The internal structure or the support structure of the wing was also done on SolidCAM by one of the suppliers. It doesn't stop there. When you eat food, a tray comes out. The tray was done by a company, a French company called Recaro in India. And all the Airbus trays are done on SolidCAM. You sit on the seats. You sit on the seats. And when you look in the front seat, there are two items coming out that are supporting the seat. Again, done on SolidCAM. So our estimate says that about 20 to 30% of the parts on an Airbus A320, A330 are all done using SolidCAM. So this company has got a major supplier base. So they do a lot of work. For example, if you see Hypermill's video about 5-axis drilling, have you seen that? Yeah? So this was done exactly in the same way, but using the generic. It has got a tube. We did not use any tube machining feature here, but we used completely generic for this, including the 5-axis drilling kind of a feature that was used to open up the part here. Now, this was for Airbus A350. This is a part that was done for Airbus A350. This is a titanium 6AL4V. This was done for a fighter jet in India. This was one of their first components that they did with SolidCAM. Then we have another part. This was done on a Makino 800Z. It was done for Boeing 737. Quite a few parts for Boeing 737 also come out from SolidCAM. And then finally, we have a stainless steel 17-4PH material part that was done for, again, Boeing 737. It's part of the door assembly, okay? And that was done for a customer called Magellan, the Magellan Aerospace. So this customer has been with us for the last 10 years. He has been approached by various vendors. He used Cimatron, he used Move to Autodesk for Power Mill, and he was approached by everyone that you know about to try and convince him to move to their product. But it was very difficult. He keeps on adding licenses year after year. Today, he has approximately 10 5-axis licenses. Not just 3-axis, but full 5-axis licenses. And what does he have? He has got 86 machines. Out of that, 90% is 5-axis. He has just placed an order. Yesterday, Natalie talked about those big deals that both Airbus and Boeing received. A lot of work is coming here. So he just placed, as we were flying into Istanbul, he placed an order for 26 Makino 5-axis machines, horizontal 5-axis machines. Okay, he's buying another plant to put those machines here. So he has machines from Makino, from MAG, from Mazak, he has got a line of at least about 9 Variaxis i700s. He has a Citizen L32. Unfortunately, we are not even able to sell him a license for Swiss type because he makes very simple parts. He has a line of Haas, probably about 40 to 50 machines of Haas that he has. And he has a 5-axis machine that's probably from Haas. That's the only machine sold in India. He has that machine from Haas. And then he has this machine from Netherlands called Unisign. This is used for making those wing structural components because it's a huge machine and it can tilt only plus minus 15 degrees. So that's the kind of machines that are there in this company. He doesn't use Cimatron E anymore. He has stopped it. Autodesk Power Mill he uses only for very old projects. CATIA, he was forced to buy because any aerospace customer today in the world has to use CATIA because the data comes on CATIA. So he uses CATIA to read and write the data. That's it. That's the only work he has on CATIA. And then he has got 10 simultaneous 5-axis licenses that he is using to run all those 86 machines that he has today on SolidCAM. Post-processes, documentation, everything comes out from SolidCAM. This customer has given me the confidence that we are the best. Okay? He comes and tells us, you are the best. Believe it. Sometimes we don't believe, but my customer comes and tells me that you are the best. Believe it. Look, the entire world is running on your product. So believe it that you are the best. Thank you.